All right. So Isaac Newton found that the temperature of something heated will cool down at different rates depending on the rate of the environment in which it's cooling. If you take physics your senior year, you'll probably study this some. The Newton's law of cooling equation was derived based on this function. So here's Newton's law of cooling right here. T of T is the temperature of the object at time t. T sub E is the constant temperature of the environment. T sub 0 is the initial temperature of the object, and K is a constant that depends on the material properties of the object.
How many T's were in that sentence?
Lots. Yeah. All right. Look. Fill that out. Newton's law of cooling, student notes, vocabulary and variables, fill that out. I just told you every single thing that goes in there. Hint, it's in the paragraph I just read to you. All right, you got it? Yes, no? All right, if you look at the, you can keep writing, we're just going to talk for a second. If you look at number 2, just look at the statement about K. It is saying that K is a constant, so K doesn't change, but that constant depends on the material. Can you think of 2 liquids that would cool at different rates, and what physical properties of the 2 liquids make that happen? Can you think of 2 liquids that cool at different rates?
Water.
Water and oil, okay, they cool at different rates, right? What's different about them? What they're made of, the density, right? All of that is true. Sometimes you can change the chemical makeup of something, makes it freeze at a more slowly. All right, let's look at the coffee problem. My only problem is not enough coffee, but let's look at this coffee problem. All right, part 1. In a 72-degree room, my 180-degree coffee will be 150 degrees after 2 minutes. I like my coffee at 120 degrees. How long should I wait? Use the info about how long it takes for my coffee to get, I don't even know what that's supposed to be, to get to 150 degrees to find K. So first of all, you have to find K. You gotta find K. How are we gonna find K? All right, yeah, let's start by filling in what we know. Okay. Do we know T sub 0?
Yes.
What is it?
180.
All right. Do we know T sub E? What is that?
72.
72. Okay. Do we know K? No. Do we know T?
2.
2 minutes. Okay. Do we know T of T?
Would be yes.
Yes.
It's 150. Okay. Now, let's solve this
Why is it 150?
because T of T is the temperature of the object at time T. So in 2 minutes, my coffee's going to be 150 degrees in 2 minutes. So this it started out at 180. It's going to be 150 in 2 minutes. That is T of T. That's the temperature at time T. Okay, so let's see if we can solve for K. What do I need to do here?
What's in parentheses?
Okay, what's 180 minus 72?
108.
108 E negative 2K. Then what happens? Divide by 108. I'm going to leave it as 25 over 18 because I want this to be as exact as possible. Take natural log. Natural log. Natural log. That's going to leave me with the natural log of 25 over 18 equals a negative 2K. So what do I do there?
Divide by negative 2.
Divide by negative 2. And whatever all of this is will be K. So let's see what we got here. Natural log of 25 over 18 divided by negative 2. That's what I got for K. Is that what you got? You better check my math because I've already told you. I can't do math today. At least I couldn't this morning.
Isn't there supposed to be a 72 on the outside of the parentheses? If you're looking at the equation.
Yes, thank you. Look how far that we just got. And there's supposed to be a plus 72 on the outside of the parentheses.
Why don't you say it?
Oh, I see.
Telling you, it's not a good day. It's not a good math day for me, you guys.
Wait until we were done with the problem to say something.
It's not a good math day for me.
So we need to check you after every step.
Probably
I
so.
don't want to have
I
to
would
check
even
all
like
of it.
wait till after the step. Like during the step, we need like 3 levels of checking. Okay, so. In fact, maybe I just won't do this. Maybe I'll just let you do it, and you tell me what the answer is. We need a system of checks and balances in this classroom. I'm going to use my yellow paper because I'm really good on this yellow paper.
I'm confused.
Oops. Oops. Yeah, don't trust me today. Did you hear all those oopses just then? Yeah. That's bad news. Alright, compare your K with your neighbor's K's and see what you get for your K's, and then we'll share out what you're getting for K.
I didn't know that.
Yeah,
Point
Yeah, me too.
Would y'all get 0.09?
That's what I got.
Pretty good.
She subtracted, like instead of the adding 72 with the 108, she subtracted 150 from 72.
What did you do?
I mean, I thought you were
I
the
had
same
them
answer.
together first and
Yeah, that's what I did.
What did you do? You would?
I was just guessing that because this is times E and that would come first.
No,
Like that would be.
no.
No.
Order of operations.
No.
That would be.
No.
You would do 108, not 72.
Are you
plus
done?
108, and then
Are you just fighting for the fun of it?
Yes. I'm not even done, and they're talking to me.
I'm probably gonna
Oh, you're not done?
It's because we're confused.
What are you confused on?
Whether we should add 72 with 108 first or subtract 72 from 150.
Order of operation.
What?
Order of operation would say that you have to,
200.
you can't touch what's in that parentheses, because what's in the parentheses is being multiplied times e to the negative 2k. So you cannot touch that first. Because here's the thing, and let's just think about that. If I was adding and subtracting 72, what would be the point of even having that
Yeah,
in the
no, that's why I
problem?
was confused.
Because it's just going to cancel each other out. So that has to be subtracted from both sides. These have to be combined because this is being multiplied by all of that. So you do need to subtract the 72 first. Because of order operation. Okay, you can do this and that in one step. They're independent of each other in this problem. What do you have on your paper? Don't erase anything yet. What do you have?
Well, I first subtracted some parentheses.
So you got 108.
Yeah, but then I added it. And I see how.
No, you can't because it's that's in parentheses and that's not. Yeah. So that can't be done.
What even negative 2? That's a negative 2.
Yeah, that's why you're confused. Yeah, that's it. That's why you're confused. It's all your fault.
Yeah, sorry. Your fault, not mine. Yes.
0.1627.
All right, are we done yet?
Yes.
Is it, are we good? What'd you get?
1.1627.
1.1627?
Yes.
What?
Wait.
Point
One
one.
point.
No, it's
Point
point
one.
Point 1.
627.
Okay, so let me see what you got, how you got it. It's not going to fit here. I'm going to have to I'll just do it on the bottom of this. So you ended up with, so what was that, like 78
78.
equals 108 times e to the negative 2k, right? And then you divide it by 108,
And it was 13 over 18.
13 over 18 equals e to the negative 2k. And then what did you do?
Natural log.
Natural log. Okay, so I have the natural log of 13/18 equals negative 2k. Divide by negative 2, divide by negative 2, and k equals what?
0.1627.
Okay, I'll take it. By the way, have we even answered this question yet? No, we haven't answered this question. Yeah, we have not even answered this question because the actual question is, I like my coffee at 120 degrees, how long should I wait? That's the question, okay? So now we have to set up another problem because now we've at least found K So we can use that K. And what are we looking for in this second problem? Yeah, we're looking for the time. We're looking for T. So do I want it to equal 150 now? No. What do I want it to equal now? 120 equals, did the room temperature change? Nope. 72, not another equal sign. Gosh. Today's not a good day. 180 minus 72 times e to the negative 0.1627 t. That is the answer you just gave me, right?
Positive.
Well, you gotta put a negative in front of the k. Negative k.
Oh, okay.
So it's like that.
So why is it negative K?
That's the formula.
Oh,
See?
okay.
Negative k. Alright, so I'm going to leave you with that one. I'm not doing the math. I could do the math, but I'm not guaranteeing anything. But I had gone back here, put the roll in like 4 times, and I think it's not put in and do that.
But
You subtract
you're supposed to
72.
subtract 72.
So,
This is
how about
multiple.
then?
Yeah. She's missing
the
a
verse, or the-
addition
that
formula.
is-
After the 72.
They're supposed to
Are
be.
there-
Yeah, that's supposed to.
Are you missing an addition sign after the 72 before the parentheses, or is it supposed
Yeah, there should be a plus sign.
Okay. You're right.
A plus sign right here. How long?
About 5 minutes.
About 5 minutes?
Yeah.
Okay.
Because it's 4.98.
4.98.
Or just get a thermometer and wait for
Yeah, you could. But you're right, it's about 5 minutes.
We could do longer, so.
About 5 minutes. Okay, good. All right, so let's try another one. Yes, we'll have a little quiz tomorrow. Yeah. All right, let's look at, flip this over. I just want to talk about number 10 for just a minute. Heating is cooling in reverse. Makes sense, right? Okay. Use the same constant, K, as in number 3. And, which y'all don't have a number 3. I'll give you the K for number 3. If an ice cube is placed in the same room, how long will it take to become 50 degrees? Okay, so we didn't do number 3, but I can tell you that the room is 70 degrees, and K was about 0.5107. Alright, so heating is cooling in reverse. If an ice cube is placed in the same room, how long will it take to become 50 degrees? And then, you know, you have to just presume that the ice was 32 degrees because it was frozen. So we're going to say it's at 32 degrees. So let's think about that one. What's going to happen with that one? You talk through it for just a minute, and then we'll talk through it together.
It's in reverse.
So what do you think? What do you think you're going to do?
Change the sign of everything.
Change the sign of everything? All signs are changed.
Guns are blazing, go for it.
So when you have T of T equals the temperature of the environment, that's 70. We're going to make it negative 70?
I think you're
No.
just change the case.
You're going to just change the sign of K? Okay, well, let's just check it out. Let's see. I want to know when it's going to be 50. So this is going to equal 50, right? My temperature of my environment is 70 plus, got to remember that. What's the initial 32?
32 minus 98.
Temperature of the environment, which is 70. Times E to the KT. And so we're going to say, we're saying that I just need to keep K as a positive this time. Is that what you're saying? All right. So that's going to be negative 20 equals negative 38. I cannot believe I did some math right just now. 5107T. So I divide by negative 38. I think I'm going to have to leave that as like 10 over 19.
Yes.
And then what do I do? Natural log? Alright. I'm going to let you finish it from here, because like you should be able to do it from there.
So I'm gonna guess this wrong.
So why do you think you got a negative?
I don't know.
Because we changed the sign.
Right. Let's think about this. You have to erase what? Okay, remember this is a fraction, right? And if you have a fraction, but you started with a number that's greater than 1, then you had to have taken it to a negative power to make it a fraction. Like 3 to the negative 1 is 1/3. The only way to get a number greater than 1 to a fraction is to take it to a negative. So one of these two has to be negative to get it here, right? Just think about this. If our room is a greater temperature than what we started with, then most likely this is going to end up being a fraction that's smaller than 1, right? So something has to be negative. So let's try it again. Let's try it again and leave that as a negative. Really, it's the last step that you have to do again. And what do you end up with?
It's the same number, but
It's the same number but positive? I got the same number but positive. So how long is it gonna take?
Like a minute and a half.
Okay. So, all right. Now let's talk about, where's your third page? Where's my third page? Let's talk about that last page. The crime scene. Corpses. I see dead people. Alright. A detective is called to the scene of a crime in a college science lab where the dead body of an unnamed chemistry student has just been found in a closet. Uh-oh. Got a DB in the closet. It's clear that the body was there for some time, possibly even while students were working in the lab. The detective arrives on scene at 5:41 a.m. and begins her investigation. Immediately, the temperature of the body is taken and found to be 78 degrees Fahrenheit. The detective checks the programmable thermostat and finds that the lab has been kept at a constant 71 degrees Fahrenheit for several days. After evidence from the crime scene is collected, the temperature of the body is taken once more and found to be 76.6 degrees Fahrenheit. This last temperature reading was taken exactly 1 hour after the first one. Based on key card entry records, it's clear that there were only 4 students in the lab the night before. The dead chemistry student arrived at the lab at 7 the previous night and never left. Edgar got into the science lab at 6, but he left at 10. Franny got to the science lab at midnight and worked until 2, and Jeffrey got in the science lab at 10 and worked until midnight. The next day, the detective is asked by another investigator, what time did our victim die? Assuming the victim's body temperature was a normal 98.6 prior to death, what is her answer to this question? Newton's law is how detectives determine time of death. Solve the crime. Find the student's constant of cooling, her time of death, and name the murderer. Why? Just because her name's Franny? Franny sounds like a guilty person's name.
Edgar sounds pretty.
No, Edgar is like the person they try to make you think is, you know, like.
Why is no one going for Jeffrey? I mean, or Geoffrey, like. Anyway, alright, that's what you have to do. You have to find out who's the murderer. That's your job. Who goes to school? What?
At midnight, they'll murder Franny.
College students go to school at midnight a lot. They don't live on a normal clock that we